I'm Gino Sigismondi, and I am with Shure Applications Engineering in the U.S. I'm filling in for your regular webinar host, Cheryl, and I want to introduce today's presenters. We have Christoph Juris, who is Applications Engineer for Pro Audio, actually based out of our office in Belgium, and Stuart Stevens, who is a Product Marketing Manager for Pro Audio, handles that responsibility for Western Europe. Both of these gentlemen have lots of experience in the pro audio world and with all of the products we're going to be discussing here today. So with that, I'm going to turn it over to you guys. Take it away.
Hi, everyone. So just a quick overview of the agenda and what we're going to cover today. So we're just going to start out with kind of an introduction to what is integration. What do we mean when we're talking about integrating Shure products? We're just going to then head on to talking about what supported Shure systems we offer. And then we're going to do a bit of a recap over some networking basics, some of the kind of things that can catch people out when integrating Shure products with other devices over an IP-based network. And then lastly, just cover some quick examples. So yeah, moving on. So what do we mean when we're talking about integration? And in essence, we're talking about one device or software talking to another device. In this case, it's generally in Shure device to share information between the two. The instances where you're most likely to come across this would be things like room control. So if you're dealing with audio-visual installations, you would be integrating Shure products into those rooms or integrating with a control system to manage things like battery monitoring, monitoring of our RF levels within that space, and just performing some basic functionality like perhaps gain adjustments or channel muting, those sorts of things that would happen within a given meeting room or space. There's software integration. So this could be integrating a software platform to trigger multiple instances or multiple events happening at a particular time, or kind of like a scene recall functionality for applications like theater. We have device integration, where this is often where the actual device is slots into another device to manage that control. Examples of this are portable wireless receivers, where you can see there it would slot into the back of a camera, and then you would be able to make some parameter adjustments on that receiver through an interface on the camera. It just kind of simplifies the workflow. Another common example is slotting portable receivers into field recorders or kind of multi-couplers and allowing you some control of the wireless parameters through your mixer. And then lastly, in the focus of this webinar today, is your traditional digital mixers that you would see at theaters, at live events, at tours. Your large format digital mixers. So when we're talking about room control, as I've mentioned, typically what we're doing in this application is we're looking to take the Shure devices that have been installed. And in the case of room control, this might be a wireless system. It could be one of our integrated systems products like the ceiling array microphones or any of the array microphones. And we're just looking at interfacing it into generally a control platform. And this would essentially be a single kind of hardware platform that you would only have a touch panel within the room, and it would be your kind of main control surface for everything within that room. So in addition to integrating with Shure products for things like monitoring of your audio levels and mute status, you may also be integrating it with other devices like projector systems, lighting systems, and so on. It really just serves as your one central control interface for all of the technology within that room. And that's why we typically see these used in kind of corporate meeting room spaces, your higher education spaces, and mixed use. So lecture halls, auditoriums, multi-purpose rooms, you would have some form of control interface. Then from the software point of view, I don't know if you want to talk us through some of the software integration options available, Christoph.
Yeah, sure, Stuart, thanks. So one of the software platforms I wanted to talk about today is Companion. As Stuart just explained, room integration is physically typically integrated into meeting rooms and conference spaces, stuff like that. where we see Companion is a piece of software that's typically more used in the live audio world, in the video world, in the lighting world. And Companion is basically a piece of software that can talk to a set of devices as long as they're networked and they're connected to each other and Companion can speak to them. You can basically give them remote commands. Since a couple of months, years, I think now, Companion has fully ready Shure modules. And what that means is basically that all the commands that you need to control Shure receivers are basically already in there. So you see a screenshot here of set channel name, mute and unmute channel, set audio gain, basically being able or allowing you to change settings on that receiver remotely. Now, Companion is a piece of software, but if you want to actually remote control it from a hardware platform, there is a device called Stream Deck that connects to the Companion software. And this allows you to assign buttons to certain actions. And what you see here is, for example, a +1 dB audio gain, a -1, a display of the current gain, the battery level, and so on and so forth. So there's loads of possibilities with this, allowing you to completely customize an interface that you would like. Now, something that we see quite often at live shows is a software platform called QLab, typically used to trigger audio files, play multi-tracks, trigger video files, and so on. And what QLab allows you to do as well is transmit TCP/IP commands to any device connected to the network. So we've got quite a few shows where we already start seeing QLab integrations to Shure receivers, basically by saying whenever we hit this particular cue or this particular scene in the show, we want to, for example, mute or unmute a PSM 1000 channel, or, for example, mute or unmute a transmitter via show link. So the possibilities are endless. As long as we support the remote control command, QLab can basically execute it remotely. So I guess that kind of gives everybody an idea about benefits of integration. So obviously, the biggest one is being able to see channel and device information remotely and see what's going on with your transmitter and with your receiver, which allows you to streamline adjustments. If you want to make a gain adjustment, you don't have to do it from the receiver. You can do it straight from the desk or from the device that you're working on, which in its turn then makes quicker, easier troubleshooting. In case something is wrong, you don't have to look at 3 different positions, but you've got all the information together at your fingertips on one screen. And then, like example, the QLab, being able to automate operations triggered by third-party software. So imagine if you want to mute 100 channels at the same time, you could automate it with QLab to say, I'm just going to send the command to the 100 channels at the same time. But for this webinar today, we're really only going to focus on mixers and how to integrate transmitters and receivers onto mixers. So an important thing I want to mention there before we start further on in this webinar is that Dante is not necessarily integration. So you have the option of using Dante audio, but not integrating it to your console. And you have the option of integrating microphones into your console, but not using Dante audio. And to explain that a bit further, we're going to talk about networking. Before we move on there, we're going to talk about the supported systems. So, Stuart, can you tell us a little about which systems we actually support?
Yeah, so as you mentioned, Dante is a nice feature, but it's not a prerequisite for having integration into digital mixing consoles. Shure produce a number of systems that are non-Dante products that you can still integrate within these consoles. There's just a few additional steps you need to take to match the chosen analog input in that console to the correct receiver so that the information you're receiving on the mixer is relevant to that analog input channel. If you are using Dante products like ULXD dual and quad receivers or the Axiom digital platform, it really simplifies things. It means that when you mount that Dante channel or assign it to a specific channel on the mixing console, it knows that because channel 1 is my Dante channel input 1, the information that I'm receiving about channel 1 should also be presented on this channel. The one non-Dante product that isn't shown here is the former Axion analog system. So that is also available for control on mixing consoles. But as I mentioned previously, as that was not a Dante-enabled product, you would still have to create the assignment between the audio side, which is analog, and the digital information that is coming into the console for that control aspect. So as we move on then, what else is required? The biggest issues we see that kind of cause integration to not work. So you have everything largely set up. You've got your console, you've got your Shure approved or Shure supported systems available. We deal with a lot of issues that are related to firmware. So not only is it best to always ensure that your Shure equipment is kept on the latest firmware for maintaining integration, but also different manufacturers will have their own versions of firmware for their consoles. And in some cases, you need to follow a process to update the console separately from any kind of Dante cards or Dante hardware that is installed within that console. So it's always really important to go through any kind of firmware update notes that are released from console manufacturers, go through the release notes before upgrading any of the equipment to make sure that you've just read it once and then read it again to fully understand what changes have been made or what impacts or this upgrade is going to have. But I'm going to say 99% of the time, if everything is on the latest firmware release, the integration is a smooth process. There's relatively little headache involved. And then lastly, one point to make on integration is that Shure makes all of the information available, like our command string documents, which basically is the syntax for how you can integrate with Shure programs. So if you're interested in programming yourself, it is possible to create your own programs that can read and write information to Shure devices. But all of that is stored on a location that we call the tech portal. So you're able to go to this address, look for the products that were supported as shown, Axion Digital, ULXD, and find what we call the network command strings documents for those. And it's that networked command strings document that details the correct way to develop an integration with a Shure product. So the important thing is it's less about who we are compatible with and more about which companies or which platforms have done some additional development work on their side to create a method of integrating with our products, because a lot of the information necessary is freely available at that tech portal side. And as we've kind of, yeah, go ahead, Christoph.
I just wanted to add, Stuart, that's also for the, let's say, tech enthusiasts on this call that say, hey, I know a bit about coding and I know a bit about sending TCP/IP commands to certain devices. This documentation is all freely available. And if you feel inclined to give it a go yourself, definitely have a look at the tech portal, and all the information is there if you want to come up with your own integration.
Yeah, that's true. But that is one of the biggest kind of things that catches people out for digital integration is it's the fact that firmware always causes issues and trips people up, and also all the information necessary for integrating the two products is available on our website. So it's not the case of telling us sometimes you need to integrate with this mixing console I'm using. It's more about putting pressure on the console manufacturers to say, we're using these devices. Please, can you develop some firmware or work on integrating it so that I can control it from my mixing console? The next thing that often catches people out is the networking side of things. So we wanted to spend a bit of time just going through kind of recapping some networking basics and just, again, talking about some of the stuff that can catch people out.
Yeah, so I think that's a very good point, Stuart. It's from the, let's say, the support calls and the questions we get, it's that you've talked about firmware and making sure everything's compatible. But fairly often we've seen that everything is at the right firmware level, but for some reason the stuff isn't talking to each other. And we know this subject isn't the most glorious or exciting subject to talk about, but in the end, it's really important that, well, your mixing desk and your Shure receiver can talk to each other. Otherwise, the integration just doesn't work. So to understand some of the stuff we need to look at is a few basic network fundamentals. So one thing we already mentioned is Dante or whatever other digital audio protocol isn't necessarily required for remote control. But the essential basis that we have to achieve is that the control ports of the wireless device, so it could be your QLXD or Axion Digital or ULXD, need to be in the same logical network as the control ports of the mixing console. Now, as we dive into that, we set a logical connection. We basically need to distinguish between, on one side, a physical topology. So this is basically where do you plug in the cable and how does the cable run and which device, switch or router or whatever is in between the device. And on the other side, the logical topologies. And we'll get back to the logical topologies in a couple of slides, understanding that it's not necessarily because there's a physical cable to one point to the other that it also makes a logical connection to those devices. So when we talk about physical connectivity, then one of the things you can do is simply daisy chaining. If you configure it could be your Dante card, it could be your Shure receiver, but if you configure that device in switched mode, basically meaning that you disable the secondary port, but you just have a 2-port Ethernet switch, in that case, you can basically daisy chain all of your devices one after the other to connect them in a single row. Now, elementary networking basics dictate that they prefer you not to do this for more than 7 devices from whatever your core switch is. There's a lot of consequences. It doesn't necessarily break the network, but it has some knock-on effects. It won't break or stop your communication, but there's good reasons to not do it that we won't go into today. But if you're only got 4 devices with you, you don't have a switch with you, this is a good way to get a couple of devices connected to each other easily and quickly. If you can, and if you bring a switch along, we prefer a star topology, which means that you connect all of your devices together to a central point, and each device has its own cable and its own physical connection to a core switch. And from there on, it can connect to the rest of the network. So that's talking about physical connectivity. Now, we also have to bear in mind that as audio and the sound industry is becoming more and more digitalized, that there's not just a network. There's multiple protocols, multiple things that need to communicate with each other, which means that a lot of these devices today, even though they have a network interface, they're used for multiple purposes. So traffic may share a single network interface, but it could also be multiple network interfaces on the same port. So what are some examples of these protocols that run over this interface? Primarily, and that's what we use for integration, it's the Shure control. So for example, we use it in Wireless Workbench and WaveTool and other software applications to communicate with the device, but it's also where the network command strings come in from your Yamaha or LN console to communicate with the receiver. On the other hand, and this is more for the mixing desks, there's mixing control, and most console manufacturers separate this. So they say on one side, we have an interface talking to the receivers, but we also have an interface to talk to, let's say, an iPad for remote mixing, or to interface to their software platform to do to download a pre-generated mixing session that you want to download to the console. And then lastly, and most people are familiar with this, it's the Dante network audio protocol. So basically the digital audio going from the receiver to the console. So at the start of this explanation, I said on one side, we've got physical ports and we've got logical ports. So what we see on this first part here is basically a Dante card, which is in switched mode. So there is only a Dante primary, but that will have a particular IP address on both ports. And there's Shure control that will have a particular IP address on both ports as well. So this is a nice example of if you plug in a physical cable to this primary port, you will have two logical connections, one to the Shure control and one to the Dante interface. If you switch this card to redundant now, all of a sudden you're going to have three IP addresses. The Shure control IP address is still accessible on the primary port, and the primary audio is also accessible on the primary port. But the secondary audio is going to be on the secondary port. So why do we specifically call this out? If for some reason you have your audio connected over the secondary network only, you will not be able to access this Shure control anymore. For people who want to fully split the primary audio and the Shure control on separate networks physically, there is the option to go to a split mode where basically the Dante interface will go on the secondary port and Shure control will be on the primary port. And this is valid for all ULXD receivers. If we go to the Axion digital receivers, we've got two extra ports on the back. And in a split redundant mode, you will have Shure control on control 1 and 2, and you will have your Dante interfaces, the primary and the secondary on the two right ports. Why is this important? Let's bring up the next slide to clarify this a bit more. In case you connect your Dante primary 1 to your Dante primary 1 and your Dante secondary to your Dante secondary, there's still no logical connection from the control port to the control interface of your mixing desk. As we explained before, you can see on the bottom here a screenshot of the network configuration of this device, and you can see that there's one particular IP address basically referring to this orange arrow, which is the control network. Then you've got a primary Dante and a secondary Dante referring to the two IP addresses for this part of the network. When we say your receiver and console need to be in the same logical network and being able to communicate to each other, it means that we need a connection from this control port to this particular control port on the console. So that's why we said at the start, it could easily be that you've got your Dante up and running, but that the remote control isn't working. And one of the reasons could be that you don't have your control port of the mixing desk in the same network as the control port of the receiver. So we brought up the concept of IP addresses. There's quite a bit of explanation that goes into making sure that IP addresses are in the same subnet and in the same range and that they can talk to each other. So Stuart, can you tell us a little about some extra details about these IP addresses?
Yeah, so we kind of just went straight into networking there without really clarifying these terms, IP addressing and subnetting. And it's one of those things where digital consoles have now been around for a number of years. We're starting to see a generation of live engineers that are very familiar with the concepts of networking, but we also understand that networking is still a little bit kind of unfamiliar to the audio engineering background. We got into this industry to mix shows and deal with audio. We didn't expect to be put in a situation where we would have to kind of have an understanding of networking. So just on the topic of IP addressing are used as that logical endpoint or destination within a network. And we say logical because it can change. It's not physically tied to the hardware. In the same way you can go into your network settings on a laptop and change your IP address, you can change the IP address of your wireless receivers and consoles to anything else to suit the network it's on. The main criteria are that each device needs to be on its own IP address to avoid clashes. It's a bit like a telephone number in that respect. You couldn't all share the same phone number because you wouldn't know how to route the telephone calls. The switchboard wouldn't know how to route the telephone calls to the right person. So each device needs to be unique in its IP address. And largely, when we talk about subnets, that is the purpose of splitting what could be quite large IP networks down into smaller segments to minimize unnecessary traffic. Called a broadcast message. Every device will kind of ping out a broadcast message at one point. And if you have a lot of devices on your IP network, if it's quite large in terms of how big that subnet is, it can cause the network to slow down and just really, it's not an efficient way to manage IP-based traffic. But in order for those devices to communicate, they do need to be in the same subnet, which is a key point. And it's why IP addressing and subnetting are quite closely related. So in terms of how an IP address is structured, we know it as the familiar kind of 4-octet address of, in this example, 192.168.100.1. But in terms of how devices and how your computer interprets that, it is made up of 32 bits or 4 bytes in total. The reason we use that terminology of the 4 octets with your 192.168.100.1 is because it's a lot easier for us to remember that than it is to remember the 32 bits. I'm sure we would all be driven nuts if every time we had to configure equipment for a show or change the IP address on our laptop, we then had to sit down and write down 110000000101 and so on. It makes sense for computers because they work in bits, but for us it's a lot easier for us to deal with it in this 4-octet view. And then it's the same with subnetting. Oh, sorry, I've jumped ahead there. In terms of how we actually get an IP address, there's a few different options. The most popular one is to have what you call a DHCP server. So that stands for Dynamic Host Configuration Protocol. And this is a protocol that was designed by the Internet Engineering Task Force to automatically assign addresses to devices when they join a network. So what happens is that device, you will physically plug it into the network, into the switch. And if you have a DHCP server present on that switch, as the device joins, it will put out a request to say, hey, I'm new on the network. Can you please assign me with an IP address? The DHCP server will receive this request and it will maintain a table of everybody else that's on the network, what addresses have already been assigned, and it will assign a unique address to this new device that's just joined. And you can configure your DHCP server to assign however many addresses you want in terms of quantity and in terms of what kind of subnet you want them to fall into, which is what drives that 255.255.255.0 number you see underneath. That defines the subnet that 192.168.1 address falls into. If you don't have a DHCP server, what you will have come across, I'm sure, is this 169.254.x.x address with that 255.255 and then 20 subnet. And this is what is called link local addressing, or Microsoft sometimes refer to it as automatic private IP addressing. But it operates in the same way. The device will join the network and it will send out this request for a DHCP server. If it doesn't receive a response, it will fall back to a 169.254 address that is automatically negotiated between the devices on the network. And the reason there's a difference between the two subnets in this example, so you have the 3 sets of 255 with the DHCP example and the 2 sets of 255 in the linked local example, is because that the way a subnet is structured means that the 2 sets of 255 create a much wider pool of IP addresses that are available for devices. In the first example, you would have 254 potential devices on your network. And in linked local addressing, you would have over 65,000 potential IP addresses available to you. So you can see there's a lot of IP addresses available there that you just simply wouldn't run out if you were establishing a large network with nothing but link local or without a DHCP server. And in terms of subnetting, the reason that it is so closely related to IP addressing, if we move forward, is that it follows the same structure. It is made up of 4 octets, or those 32 bits or bytes, and its purpose is to identify how much of that IP address is my network and how many of those IP addresses are remaining for hosts for specific devices. And changing the size of this subnet mask changes the size of the network and also changes the amount of hosts that are available for devices on the network. So as you can see in this example there, or the example we had previously, that IP address 192.168.1, because those decimal subnets of 255, 255, 255 underneath it, that represents the network portion of the IP address. So in this case, we would say that this is the 192.168.1.0 network. .0 would identify the network in this case, which means that the first available IP address for me to assign to a device is .1, because those subnet bits all line up, which identifies the network. .1 then is my first address available for hosts. And we can actually go forward, like I said, to change the size of our network by manipulating the size of the subnet mask. So in these examples here, you'll see that the link local subnet mask of 255.255.0.0 at the far right gives me a potential 65,534 hosts. So it was chosen by the Internet Engineering Task Force as a suitable subnet so that you would always have a huge amount of link local IP addresses available. If you are running a network with more than 65,000 hosts, you shouldn't really be using link local addressing anyway, but it just shows that kind of they definitely planned ahead when they came up with this technology. The /24 notation, or the 255.255.255.0 subnet mask that we see most frequently, signifies that we have 254 hosts available. Now you'll notice there it says block size of 256, but we have 2 less for the number of hosts. And the reason for that is, as I mentioned during one of the previous slides, the first IP address, the 192.168.1.0, identifies the network. So that is not available for any hardware devices. The first IP address would be .1 and so on. The last IP address is reserved for what we call broadcast messages. So if you need to send a message to every other device on the network, you would address it to that broadcast address, and then other network hardware like the switch knows to share it out to every other device on the network. So you can see why, if you had a large network like the 255.255.0.0 network, if every single device is perhaps exchanging these broadcast messages, you can see that there's a lot of unnecessary traffic that could occur. And by implementing subnet masks, it allows us to kind of shrink the size of these networks down and make them more manageable. There are the options to extend the subnet masks even further. This is extremely rare in pro audio applications, but it's worth mentioning. And one of the things that we always like to highlight, particularly in our audio networking webinars, is a lot of this might raise questions about, well, why do we do it like this? And it's because we are using the same technology. As I said earlier, the Internet Engineering Task Force, a lot of these kind of protocols were developed to facilitate huge networks like the internet. So in that case, you might want to be able to subnet down even further and really minimize the size of your network down to as far as 2 hosts. You could go as far as 0, but that's not a network at that point. So you can see for that example, when you see .128, you end up with 126 hosts, essentially cutting the previous usual 255, 255, 255 network in half. And we would end up, 126 hosts across 2 separate subnets then. That's a fair amount of information to take in. So the one last bit I will leave you with, in addition to IP addressing and subnetting, is just a couple of examples just to help it sink in. We can see here that IP address is that 192.168.1.1 address. We have that /24 or the 3 groups of 255.0 subnet mask. So going through these examples, we can see that the first example would, of course, fit within that network because the 255s identify the network portion, and as that last octet is a 1, it signifies that it is within the correct network, and therefore it is a unique IP address as well, because the last octet of the 2 tells me that it is not being used. Well, it shows that compared to the .1 of the example, it's an available IP address. Examples 2 and examples 4, you can see, would not be valid because although it starts with the 192.168, the .2 in the third octet is different from the original example. So as the subnet mask dictates, the third octet must be a 1 in order for it to fall within that network. Those IP addresses would not be valid and the devices would not communicate. Lastly, then, the only other thing that can catch you out when it comes to kind of integration or visibility of devices in software or communicating with these devices is the actual ports and protocols of the hardware itself. So we use a number of ports available to facilitate communication within our devices. If you are using firewalls or have kind of corporate controlled firewalls on your devices, it's worth just talking to your network administrators and making sure that these specific ports are open. Particularly that one I wanted to highlight, 2202, about midway down through the table there, where you can see for AMX/Crestron control strings. We've called out AMX and Crestron there because those are 2 major manufacturers of the room control systems I spoke about earlier, but really that is any control string. If you want to integrate with kind of open source software that you've written yourself, you will need to facilitate traffic through that port 2202. So
maybe
that was,
one of
One
of the things I wanted to add, Stuart, is that if you are running, let's say, a box standard live sound network, which is consoles connected to receivers on a switch, these are all things you do not need to worry about. This is more if you work in an environment where your console connects to a network that connects over multiple rooms and you have an IT administrator, then this is typically the information you will need to share with them. So it's very important to notice, I think, that well, if you're running your own network, you only have a switch, then this is something you do not need to worry about.
The thing with networking is kind of treating it in the same way as you would treat audio. Is when it comes to troubleshooting, don't jump straight into things like IP addressing and subnetting. Start at the ground, check your cables, and work from there. So that's cables and firmware is where I would recommend we start. Now, do you want to just take us through a couple of examples, Christoph?
Sure. So we've been talking a lot about how to set up your IP addresses, how to connect your devices together. But then once we get to the console level, I've created like a list of stuff I've noticed, things that have caught me out in the past, and things you're probably going to need to take into account when you're trying to integrate to your mixing desk. So for Allen and Heath, the control port is a separate physical port on your console from the Dante ports. So you will need to configure that control port to a particular network other than your Dante devices. Now, in some of the newer software versions, and I'm not the Allen and Heath expert here, so unfortunately I don't know which one, that they've added the option of actually software linking the two together to say, yes, my audio is on, or my control strings are on my primary Dante, and it will physically, well, or logically at the surface link the two network interfaces together. If not, some tips and tricks that I've heard from the field is people who leave their Dante cards in switched mode and actually put a small network cable between the control port from their desk to the secondary port on the Dante card, and that will physically connect the two interfaces together if you don't want to do it in software. So that's one of the options you can do. Then when we go to Yamaha, Yamaha is a bit particular when it comes to naming the devices. For the Yamaha users on this call, you may have noticed by now that your console has a console ID that you need to set, and there can't be two consoles on the same ID. The same goes for their Rio stage boxes. They have a rotary switch, or the newer ones, a digital touch, or is it buttons anyway, a display to set the ID. And that needs to be unique as well. So Yamaha users will have run into the situation where you've got two stage boxes set at Y001, and then it only finds one of the two, or it doesn't find them at all. Yamaha have taken that topology into remote control for receivers. So your receiver will need to be named Y001, Y002, and be indexed like that to have a unique name for each receiver. And to that purpose, Shure has incorporated a Yamaha mode in the receivers. And what that will basically do for you is make sure that you set that Y001 dash before the device name of that receiver. But there as well, take into account if you've got a stack of 4 ULXDs that they're not all set at Y001, because this will stop them from being discovered on the Yamaha console. Another thing to take into account is that the control port, other than on Allen and Heath, is physically on the primary Dante port of the console. Basically meaning if you've got an Axiom Digital and you've got it to split redundant, then it takes that control port away from the primary Dante. So either at your switch or by a small jumper cable, you will need to combine those two networks again. Because you need to make that control information available on the primary Dante port of your Yamaha console. The third thing to take into account is that when you go to the network configuration page on your Yamaha console, there are two different tabs for your setting your IP address and subnet, as Stuart just explained. One of these tabs is to control basically the control interface that's attached to your primary Dante port. The other one connects the small little Ethernet port that's on the side of the console for your iPad mixing. So it's definitely something to look out for if you say, well, I've checked it all. We are in the 192.168.0 subnet, and I've checked it all. Make sure that you also look at the bottom of the screen that you're on the correct tab for device control and not for mixer control, because those are two different logical IP addresses. If you're finally deciding to use non-Dante devices, Yamaha is actually pretty good when you're using Dante devices. They say, well, you're taking the audio from this receiver, so my assumption is that you want the same channel to give you the RF information about the same channel that then that's generating your audio. So it works pretty well if you use Dante routing. If, for example, you've got a QLXD and you don't have Dante, then there is a wireless menu where you need to assign each receiver to its particular channel. So you will need to manually say, my stage block input 22 is actually this particular QLXD receiver, to basically match the information of the receiver to the channel. And then finally, on a Soundcraft console, you need to connect to the high QNet port on the device. And one of the things to notice there is that the wireless monitoring is not on by default. So if you just connect everything together and you go to the device menu, you won't actually see your receivers, because in the wireless monitoring menu, you have to say enable receiver control or something, I think it's called. But if you don't particularly select that option to on, it will not even try to attempt to connect to receivers. And then much like on Yamaha and on Allen and Heath, if you're not using a digital audio stream, you will need to match your receiver channels with the actual audio patch points. So there's a particular tab to do that as well. Now, we considered explaining for each console in depth how you need to set all of this up. But it would have made this 1 hour seminar or webinar a 4-hour webinar, and we didn't really have time to do all of that. So what we're doing at this point is directing you to the setup guides and setup videos from all these particular brands. And basically after this webinar, take the time to visit these YouTube videos or read those setup guides, particular to your software version or your particular mixing desk. For people who want to open these files in your GoToWebinar overview screen, that should be open somewhere on your laptop, there is actually a link to a PDF handout, which will allow you to just click to these links directly, so you don't have to write them down or copy them. So if you don't find this particular PDF, let us know and we can provide it to you later as well. So I hope it's been helpful, and at this point I'd like to open it up for questions and see if there's anything else you would like to ask us about this.
So let's get into some Q&A here. There's only a few questions, so we should be able to get through these, but don't forget you can still ask questions if you've got them. So this first one here is asking, this was from much earlier in the webinar, what is the hardware interface bus used for Shure integration products? Is it proprietary to Shure?
A bus, I mean, we use a TCP/IP protocol, which is an open standard. They're all unencrypted ASCII characters. As Stuart mentioned, it is on port 2202, so that's public information. They're all human readable ASCII characters. That said, yes, it's proprietary to Shure, the way the syntax is formatted. So the way you structure that message is something we came up with, but the nice thing is that it's standard across our platform. So set gain to this level would be the same on all our devices.
Mm-hmm. Yeah, and if it's referring more to the audio, of course, as we've mentioned, if you're talking about audio networking, that's Dante, which is not, proprietary to Shure. So
yeah,
let's see here. Are Dante and LAN ports the same? I can see my Axion mics and Dante controller through the LAN port only. And that sounds like referring to maybe the differences in, split mode versus switched mode and that sort of thing. So I think the answer, correct me if I'm wrong, is sometimes they're the same and sometimes they're not. It depends on how you've got it configured.
Exactly. So that's where we made the differentiation between physical ports and logical ports, because exactly as you say, Gino, if you basically switch an Axion Digital to switched mode, which is in the network menu, you will have your two logical interfaces, your Dante and your Shure control, on all 4 physical ports, and you will see them together on the same interface. If you go to the split redundant mode, which is another configuration there, it will physically separate those 2 logical interfaces. So I think you're spot on by saying if you only see the one of the 2 interfaces on your network, it's probably because your receiver is in split redundant mode.
Mm-hmm. And then I think this question is very similar, but it's saying if you have 2 Axion units, can you connect them together via the secondary and then take the primary to the mixer? So two units connected via the secondary. Again, if it's in switched mode, yes, right?
If it's in redundant mode, no.
Yeah.
But there's that side note. If you have 2, yeah, go for it. Put them in switched mode and connect the secondary to the next receiver. If you've got 10 on top of each other, I would strongly recommend purchasing a switch.
Mm-hmm. Yep. Let's see, another question about accessing a recording later on. Yeah, just to make sure that that's clear to everyone, there will be a recording available in about a week at shure.com/webinars. Let's see. And again, can wireless workbench work at the same time as console integration?
Yes, yes, it can.
Yeah.
Likewise, same usual practices as long as your laptop's in the same subnet and has a unique IP address, that device discovery will work for Workbench as well. So,
And then a follow-up question, really kind of, I think we're asking the same thing, but also noting tablet remote control, which of course would be the Shure Plus Channels app, and I believe the answer would still be yes there as well, right?
yes. Yep. I mean, there's like, as long as it's still all in the same IP subnet and they have unique IP addresses, it's still the same network. There's no limit to the number of devices that you can send a message to. And it's not uncommon. We see users, especially in the touring applications, with the advent of kind of remote mixing tools on iPads, they will have a Wi-Fi router at front of house or monitor positions to just have the iPad free the Shure Channels app, or for one of the console manufacturers' remote mixing apps, and that can all coexist on the same network.
Great.
I think we're also pretty solid at making sure that these all update in real time. So what you'll easily see is if you adjust the gain on your mixing desk, you will see actually the gain level in Workbench adjust at the same time. So they can all coexist in the same network and display the same information.
Great. Okay, well, that looks like it's all of the questions that we had for today. Oh, wait, one more just popped in. That always happens as soon as I say that. Let's see. Just to be clear, if I'm running a Yamaha CL in redundant mode, I need to bridge the two ports. As it is now, I can see and hear the mics, but cannot control them.
Feel free to chime in as well, Christoph, but Yamaha expects to see Shure control information on the primary Dante network. I'm making an assumption here that if you're running a redundant setup, you either have a primary switch and a secondary switch. So one of the easiest ways is to just create a network loop from the Shure control side of things to that primary Dante network, which will put the Shure, when we talked about those different traffic types, that will put Shure control traffic onto your primary network. Or I believe, Christoph, you have a little trick where you can do a kind of loop from one port to another on an Axion Digital.
So most Yamaha users that use Axion Digital and run Dante redundant, what I do is take a very short patch cord, take the Dante primary out, plug it into control 1. That basically merges the logical interface of the control and the Dante in one port. And then I take control 2 out, that goes to my primary switch. So basically at the back end of the Axion Digital receiver, I merge the control and the Dante audio together. Now, the second thing, if you've got Dante audio, but you're not seeing them, also check out whether your device is in Yamaha mode, because that's something that catches a lot of people with Yamaha desks out. If you don't have that Y001 incremental numbering on your receivers, it will not detect them.
And let's not forget checking your firmware, right? Always making sure you're on the right firmware versions. Yes. And there's a follow-up to that. Just something I was going to add, and I think this is correct, but I'll ask it for everyone's benefit. There is no way to retain, if you're on a redundant network and it fails over to the secondary network, you would lose the Shure control then. There's no way to have Shure control on both primary and secondary, right?
Yeah, that's correct.
At that point, you have to be clapping your hand that you didn't lose audio.
Mm-hmm. Right.
Yeah,
exactly. Here's the inevitable question that we knew we were going to get: SLXD, and that's the whole question. SLXD with 2 question marks.
So this is one of the instances where why we highlighted it during the presentation is everything that is required for console integration is available, and we have good relationships with console manufacturers, but they also have their own feature requests and firmware priorities. So if you want to see SLXD on those consoles, I would encourage you to contact those console manufacturers and submit the request. The more requests they get to say, hey, I'm using Allen and Heath or Yamaha or Soundcraft, and I own 20 channels of SLXD and I want integration, the more inclined they are to integrate the two platforms. Unfortunately, there's, other than requesting it, there's not much else we can do from our side. The information is freely available to them. So go and ask them for it.
And follow up, do you happen to know, is Axient control available on the Yamaha, I'm going to say this wrong, Rivage console? PM consoles?
I tested it about a year ago, the Rivage PM7 and PM10. And it wasn't available at that time yet, but because they were focusing too heavily, as it's a new platform, on releasing new features. But I don't know, it was definitely on the roadmap to provide it. So it will be there at some point. I'm not sure whether it's released yet or not. So we'd have to double check on Yamaha's website to find out.
Always worth pinging Yamaha on that one to let them know you're looking for it. And Digico SD series, I don't think we have any Digico integration, do we?
No, but being a UK-based company, we know the guys at Digico well, or at least I know them. But yeah, it's another one where they're aware of it. They have a lot of people that have been asking them for it, but it's one of those things where it's in their list of features and things to do, but it's on top of developing great new Digico consoles as well. So keep asking the guys at Digico for it, and we'll keep trying from our side, and hopefully we'll get there.
Yeah. Yep. I mean, that's a great, I think, maybe kind of note to end on here too. We are, cause we're out of time. Again, as you've noticed here, it's kind of a two-way street when it comes to, how we get this integrated, right? We can do our part. We need the console manufacturers to do their part. And the same goes for making it work as well. So you want to make sure that you grab that handout that is available with the links to the other console manufacturers and their instructions, because you take it so far on the Shure side, you finish it up on the console side to make sure that everything is working correctly there. So definitely grab that. And again, if you're looking for a recording of this webinar, we should have it posted in about a week at shure.com/webinars. So thanks everyone for attending today, and have a good week. Take care.